So you'll see the definition as they read it. Let f be defined on interval I containing c. It means it's not undefined. We don't have an asymptote or a hole or something. F of c, that's your y value, minimum. If f of c is less than or equal to f of x for all x, is it the lowest point? F of c, y value, is the maximum. If f of c is greater than, is it the highest point, okay? So visually you can see what highest and lowest is. These are called the extreme values or extrema of the function. The minimum and maximum of the function on the interval are also called the absolute minimum and absolute maximum. Now here's the difference between relative and absolute. Relative means the function can continue and somewhere else it can be higher, especially if it goes on to infinity, right? So if your endpoints go on to positive infinity, you wouldn't have an absolute over the entire thing. You could only have an absolute in an interval, right? Relative means I'm talking about the entire function, and this is the highest value relative to the numbers around it, if so to speak, if that makes sense. So that's the difference between absolute. That is if it's like a closed interval, and these are legit the absolute, or think of a parabola. A parabola has an absolute, either max or min, depending on which way it's facing, right? If it's facing up, you do have an absolute min because it doesn't go on. But polynomial functions can kind of turn and all this, and so you might have some relatives over the whole thing, or you could have an absolute within an interval. So, and you can have more than one relative, obviously. It could be a relative max here, a relative max here. You could have multiple relative because it's just talking about peaks or valleys at that point. Versus absolute, there's nothing higher, there's nothing lower. Right? And then they give us some pictures of what can happen here. All right? So, f is continuous on this closed interval. So it includes the endpoints. We have a peak here, we have a valley here, we have a peak here. This would be the maximum, all right? So we have a maximum here, we have a minimum here. All right? The problem here is this guy's open. See how he's open? It does not include the endpoints. So we actually don't have a maximum. You would think the guy right below that would be it, but we're talking about an infinite set of points. So if you're talking about decimals between, that's kind of hard to give me a maximum when you're talking about decimals. We're not talking about integers, right? We're talking about rational numbers, okay? Or irrational, all reals. So we could have square roots in between them, right? So no minimum here, but maximum here, but we do have a minimum, all right? We have a hole, so it's undefined where the minimum would normally happen, okay? That does not meet my definition that said it had to be defined in order to be a minimum. So while the hole is the lowest point on the graph, it's a hole. It's not actually on the graph, right? So this doesn't have a minimum, but we do have a maximum, all right? So it has to meet all of that criteria. It has to be defined at that point, and it has to be either the lowest value or the highest y value within the interval that they're talking about. In order to be maximum, it has to be the actual highest or lowest versus a relative, okay? Extrema can occur at interior points. You can see it had occurred inside, or it can occur at the end of the interval. So it's a closed interval. It could be at the actual end. So your extrema are going to either happen at turns or at the endpoints, okay? That's where your extreme will happen. It's called an endpoint extreme, but I don't actually make you separate endpoint extreme versus turn, at a turn. I just actually make you test all the points, which is what we're gonna do. A couple things. They start to introduce this new term called a critical number, all right? We have peaks and we have valleys. Think of it as like on a roller coaster. That's where your extremes will happen, right? Or like I said, if it's a closed interval, it may happen at the endpoints. But there are ways to think about these peaks and valleys, right? And so you'll notice we have a relative max, we have a relative min, all right? And they happen where we're having turning points. And so definition of relative extreme, if it is an open interval, we're going to have relative maxes and mins. It just defined absolute because it had endpoints. So it actually closed the interval and said, we only want you to look at these. If it's an open interval, then the ends of a function are going to shoot off somewhere. And so the only thing you can have on an open is relative, because the ends are going to go off somewhere, right? And probably not create a absolute max. You're going to have an infinity somewhere. So they do tell you what the plural, by the way, because you're going to see this. Plural of maximum is maxima and minima. So when it says find the maxima, find the minima, it's just leaving it as a plural. There could be more than one. So they give you that so you know what it's talking about in your instructions. It says find the value of the derivative. So the first thing we look at when we're looking at extremes is the derivative. Why do we look at the derivative? Well, you'll notice something that happens at these extremes. If I look at this first example here on page 161, I have this function. They took the first derivative, and so 3 is where this turn happens. And when they took the first derivative and plugged in a 3, what answer did they get? 0. Now, what does first derivative represent? The slope, right? So the slope right here of this tangent line is going to be 0, right? If I were to take this tangent line, if I could get it to actually be where I want it to be, all right, you will see that the slope of the tangent line is going to be 0. It makes sense that you have a horizontal line at a turn, right? Think about a roller coaster. When you're at the very top of the roller coaster, you're facing straight horizontal, right? It's not until you start going down or going up that you're no longer facing the horizontal. And so at your turn points, your first derivative is going to equal 0, because first derivative represents slope of the tangent line. Slope of the tangent line at a turn should be 0, right? Look at my sine graph over here. You'll notice that at pi over 2, we have a turn. First derivative at pi over 2 is 0. The slope of the tangent there is 0. We have another turn at 3 pi over 2. First derivative, plugged in 3 pi over 2, 0. So there's a pattern that's happening. All of my turns are creating first derivatives of 0. So just like my question on my test, where is your first derivative 0? Not only did you find where your first derivative was 0, you also found where you had turns, right? Because you were finding the slope of the tangent line that equaled 0. It had to be a turn, okay? The other thing that can happen is this guy right here. We have an absolute value. If you were to take the first derivative of this absolute value, you would find that at 0, it does not exist. It actually is an undefined slope there, all right? Even though it looks like it wouldn't be, right? It looks like it wouldn't be. But because of this sharp turn that happens in this particular graph, my first derivative is undefined here, okay? Mostly because you have to take, you have to divide it into 2 functions when you do an absolute value. And we'll do absolute value down the road. But you have to divide it into 2 functions, and they don't work out. And so your limit theory doesn't hold here, and you do not have, it's undefined. But you obviously still have a relative min there. Clearly, an absolute value graph is going to have a relative min or max, depending on which way it's facing. It's actually going to have an absolute, right? But your first derivative is actually undefined at that point. So there are 2 things that happen when you have either a sharp turn or a nice curvature turn. At a curved turn, you're going to have a slope that equals 0. First derivative equals 0. At something sharp like this, you're going to have a first derivative that is undefined. And these are what they call critical numbers. Definition of critical number. Let f be defined at c. So we want it to be defined there. We're not going to have a vertical asymptote there, something like that. But f is defined if the first derivative, that's what this little mark here, this little hash means, first derivative equals 0, or if it is not differentiable, the first derivative is undefined at c, then c is a critical number. So if I get my first derivative and set it equal to 0, I will find critical numbers. Or if I say, where is my first derivative undefined? That will also be a critical number, all right? And those critical numbers will help you find maxes and mins, all right? Relative extreme occur only at critical numbers. This is my theorem here. If the function has a relative min or max at a point, then that point is a critical number. So when you have an interval, and they want you to find the max and min, the first thing you need to do is find your critical numbers. All right, and you need to test them. Which gives you the highest, which gives you the lowest. If it is a closed interval, you also need to test your endpoints because those could be higher than your mins that fall in between them. All right, so let's look at these. Guidelines. Find the critical numbers. Evaluate the function at the critical numbers. Evaluate the function at the endpoints. The lowest is the minimum. The greatest is the maximum. That seems pretty straightforward, okay? That's literally what you're doing. You're finding them. You're plugging them into your original function. The highest y value is your max. The lowest y value is your min. That's how easy this is, all right? So the next thing that makes you think first derivative is extrema, all right? So slope makes you think first derivative. Extrema makes you think first derivative, all right? So find the extrema of this function on this interval. So my first step here then is to get my first derivative. My first step is I need the first derivative, all right? My first derivative is easy. 4 times 3 is 12. It's going to be an x cubed. 3 times 4 is also 12. It's going to be an x squared. So my first step, find the derivative. My next step is to set that derivative equal to 0. 12x cubed minus 12x squared equals 0. And we need to actually solve this. What can I factor out? 12x squared. What am I left with? So my two critical numbers here are 0 and 1. Everybody see that? 0 and 1. Critical numbers. So these are my critical numbers. Is there anything that would make this undefined? Because that's the other piece of a critical number. I don't have a denominator to worry about a 0. I don't have a square root to worry about a negative, right? There's nothing that's going to make that undefined. Does that make sense? If I had 12x squared over x minus 1, we might have a problem, right? We could have a 0. Or if I had the square root of x minus 1, there's a potential problem there with real numbers, right? But this guy has no problems. So the only critical numbers here are where it equals 0, okay? Now my third step is to figure out what gives me the highest and what gives me the lowest. My interval is from -1 to +2. I only have to test my critical numbers that fall in my interval, right? Critical numbers could fall outside of the interval. You could have a turn that happens outside of the interval they've given you, those parameters. These both happen to be in there. 0 is between -1 and 2. 1 is between -1 and 2, okay? So now I need to plug in everything from -1, that's my endpoint. I need to plug in my critical numbers that are inside my interval, and I need to plug in my other endpoint. Do you notice I do not have a dash beside that F? Where am I plugging those in? This guy has a dash. This guy does not. Plug them into your original, okay? So for this particular process, we are plugging them into our original, which is 3 -1 to the 4th minus 4 -1 cubed. All right, so when I plug in a -1, I get 3 plus 4, right? 7. 3 times 0 to the 4th minus 4 times 0 cubed. 0 gives me 0, right? Plug in the next guy. 3 times 1 to the 4th minus 4 times 1 cubed. That's going to give me -1, right? Plug in a 2. 3, this guy is going to be a little bit bigger. All right. We actually end up with 16 here because you end up with 8 times 2 if you factor out the 2 cubed, by the way, so we get 16. Clearly, I have a max and a min, right? So where does my minimum occur?
0.
At -1. Where's my maximum?
60.
So my minimum occurs at 1. x equals 1. My maximum occurs at x equals 2. Okay? Does that make sense? Those are my min and max. So my first step is to find my critical numbers, which means I need to find my first derivative. So I am going to, first step, find my first derivative. Derivative of 2x is just 2. 2/3 times 3 is 2x to the negative 1/3. Okay? So you end up with something that looks like this. 2 minus 2 over x to the 1/3. All right? I would recommend getting a common denominator here.
That makes sense.
Just because it might be a little bit easier when you're setting that equal to 0, maybe. Either way, it's going to be kind of a booger. You can set it equal to 0 here. You just probably want to do your shortcuts of flipping, if that makes sense. So like my next step here is to set my first derivative equal to 0. I would subtract my 2. I get negative 2 over x to the 1/3 equals negative 2. Anytime what you're solving for is in the denominator, flip both sides. Trust me on this one, okay? So flip both of these. We get x to the 1/3 over negative 2 equals negative 1/2. I promise it makes your life easier, okay? And then multiply both sides by negative 2. You get x to the 1/3 equals what? 1, right? 1/2 times negative 1/2 times negative 2. And then, now the 1's beautiful because any root of 1 is 1, right? But let's say this was not 1. How would I solve for x here? Raise both sides to what?
The square cube or something?
You raise both sides to the reciprocal. What's the reciprocal of 1/3?
3.
3, both sides to 3. Now because it's 1, it's going to be beautiful. And 1, okay? But I just wanted to walk you through that because had that been anything else but 1, you would need to remember your algebra skills there, okay? You could also have gotten a common denominator here and figured out. So we have a critical number. If I found my critical numbers, I know I have one at 1. Do I have any other ones? Well, I need to go back up here and also see if anything would make it undefined. Would anything make that undefined?
0.
Yeah, I have a denominator, right? My denominator could potentially cause a problem. And the only problem that this would cause is if x equals 0. So I actually have two critical numbers here. I have one at 1 and at 0, okay? 1 and 0. So this one's different because it did have a potential for undefined, all right? Now that I know that, I am going to plug all of those in to my function along with my endpoints. 0 and 1 both fall in my interval, right? So I'm going to start with my lowest endpoint. I'm going to plug in a 0, a 1, and my highest endpoint, all right? All of these work out except for 3. 3 is hideous, right? If I plug in a negative 1, I get 2 times negative 1 minus 3 times negative 1 to the 2/3. Cubed root of negative 1 is negative 1. Then negative 1 squared is positive 1. So this ends up being negative 2 minus 3. So this ends up being negative 5. 0 makes our life so much easier, right? 0 to any power is just 0, so this guy is 0. 1's pretty easy as well. 1 to any power is just 1, so I get 2 minus 3 here, so this gives me negative 1. 3's ugly because 3 doesn't have a nice, beautiful 3 to the 2/3 power, yeah, 2/3 power. Is some decimal, and I think when you plug it in, it's like negative 0.24 or something like that, okay? I clearly have a max and min here, don't I? Where's my max? My max is actually
0.
at 0, right? My min happens where?
-1.
Yeah, right here at negative 1, right? Typically they'll say at, and they'll give you the X value of where it is. Now, when you do word problems, it depends on what it's asking for. But when it says where does it happen, it's going to be asking the X value for where it happens, by the way. Look at the graph here. So if you look at this graph, it's kind of a funky graph, right? You can see this sharp turn that happens at 0, undefined, right? And then you can see this curve happens at 1, which was our critical number where it equals 0, critical number where it was undefined. And then you can see this is the max. This guy definitely is the min of this particular graph. Yeah, so derivative of sine is positive. 2 cosine of x. This guy is going to be negative, but it's also a minus. So minus a negative, so it's plus the sine of 2x. Chain rule says I also need to take the derivative of the 2x, which is 2. All right? So that's my first derivative. All right? Where does this equal 0? Okay. This is going to draw in your memory trig identities. All right? There is a trig identity for a double angle of a sine. We'll wait for the Jeopardy theme song. Okay. Sine of 2x is 2 sine cosine. All right. So I can replace this whole sine of 2x with 2 sine of x cosine of x. That's my double angle. Y'all remember double angles?
Could we make it 4?
That's what we're going to. So we have 2 cosine of x plus 2 times 2, right? So yes, it's 2 cosine of x plus 4 sine of x cosine of x. And I, as my second step, need to see where this guy equals 0. I can factor it. What can I factor out of that guy? Between the 2 and the 4, I can factor out a 2, and I can factor out a cosine. So I have a 1 left over here plus 2 sine of x. What do I do with those two factors? Set them equal to 0. 2 cosine of x equals 0. 1 plus 2 sine of x equals 0. This is basically where cosine of 0. Where is cosine 0? There's 2 places where cosine is 0. Up top and down bottom, right? So it's pi over 2, 3 pi over 2. Yes? Okay. What about this guy? Subtract 1, divide by 2. It's where sine is negative 1/2. All right? That happens in your 3rd and 4th quadrant. Sine is 1/2 are your 30-degree angles, right? Your pi over 6s. Yes? No? Possibly? So you have a pi over 6 in the 3rd. That's 7 pi over 6. And you have a pi over 6 in the 4th. That's 11 pi over 6, right?
Oh.
Those are your 4 critical numbers. Okay?
So what about the...
How many points do I have to test? I have 4 critical numbers. What else do I need to test?
They're not in the interval, though?
They are all in the interval 0 to 2 pi. I also need to test 0 to 2 pi, right? So I really need to know all of these. I need to know where this guy, what happens at 0, what happens at pi over 2, what happens at 7 pi over 6, what happens at 3 pi over 2, and what happens at 11 pi over 6. Yeah, unit circle is very important. Now remember, you're plugging it in here. So
Wait,
2,
you also test 2 pi?
yeah, and 2 pi, but it's gonna, just a fun fact, 2 pi and 0 should give you the same results. Unless you have like an x on the outside that would 0 out. You know what I mean? We don't have an x on the outside. If there was like if we had a product rule with like an x in there, it would have mattered, but hopefully 0 and 2 pi give you the same thing with this guy. When you plug in a 0, you can see the chart. You get -1, you get 3 here, you get -3 halves here, and we can walk through how to do it. All right. What do you notice? My max is easy. Max happens right here, right? What about my min? I have 2 of them, don't I? That is possible. Extrema means plural, right? So I actually have a min that happens here, and I have a min that happens here. That's fine. It's not a big deal, right? It can happen more than once. You can have more than one. Now, if you think about plugging it in, by the way, 2 times the sine of pi over 2 minus the cosine of 2 times pi over 2, okay? Sine of pi over 2, that's just 1, right? 1 times 2 is 2. Here, it's the cosine of 2 times pi over 2. So that's the cosine of pi, which is -1. That's how we're getting our, you know what I mean? So pay attention to when you multiply. If that 2 is inside the cosine, you need to multiply what's in there before you take the cosine. Okay? So it may move you around the graph a little before you take the cosine or sine. Graph, by the way, if it will let me, there we go. So this was my graph. Clearly you see this peak here, right? And then we have 2 bumps that are the same right here. One has a